intercepts of parabolas. So as we sort of go through these important points of quadratic functions or parabolas, I want to highlight a couple of other important points that we can find for a graph. And so these points are the intercepts. Intercepts. So we have x-intercepts and we have y-intercepts. And these are the points where the parabola crosses one of the axes. And you'll recall these x and y intercepts from your previous studies of linear equations or straight lines. These have y-intercepts and x-intercepts. The difference here with quadratic functions is that, well, they usually have a y-intercept. Well, they always have a y-intercept. They can have two x-intercepts. So here's our x-intercepts and our y-intercept. Here's another x-intercept. And they can have two because they sort of have this big U shape, so they can intersect at two different points. And so another important feature that you'll have to recall is that because this is going along the y-axis, y equals 0 for all the points along this axis. So y equals 0 for the x-intercepts, and similarly, x equals 0 at every point along the y-axis. So when you want to find the y-intercept, you can use the fact that you know x is equal to 0 at that point. Every parabola has a y-intercept. Just one. But not every parabola has two x-intercepts. Sometimes they do if the parabola is oriented in such a way that, say, it's below the x-axis and opens upwards, it could cross twice, or it will cross twice. And likewise, if the parabola was above the y-axis, or sorry, above the x-axis and opened downwards, it would have two x-intercepts. But a parabola can also have one x-intercept if the parabola just happens to touch the x-axis at one single point. And it can also have 0 x-intercepts. Zero x-intercepts here on this one on the right. 0 x-intercepts. If the parabola has a vertex above the x-axis and then opens upwards, it'll never cross the x-axis. So here's an example on how to find the intercepts of a parabolic function or a quadratic function. So let's start with the y-intercept, because this is always going to be the easiest intercept to find. For the y-intercept, x equals 0. Which means y is equal to, well, just insert 0 into the equation wherever x is, and we get y equals 3. So the y-intercept is x equals 0, y equals 3. The x-intercepts can get a little bit trickier. So for the x-intercepts, we know y equals 0, which means that y, being represented as f of x, is equal to 0. So the whole left-hand side of that quadratic equation is equal to 0. And now we have a quadratic equation to solve. And solve this by whichever method makes the most sense to you. When I see this, I don't like the fact that I have a negative value in front of x squared, because I want to try factoring first. So I'm going to multiply everything by -1 on each side of the equation. 0 times -1 is still 0. But multiplying everything on the right-hand side by -1 flips all the signs, which now might make it easier to factor. So I'm looking for, can I find factors of -3 that add to -4? Well, I don't think so, because the only factors of 3 are 3 and 1. And even if I made one of them -3, the other factor would have to be +1, and that would add to -2, not -4. So I don't think I'm going to be able to solve this by factoring. I'm going to have to try the quadratic equation, or the quadratic formula. So let's go ahead and run through the quadratic formula. So this is -b plus or minus the square root of b squared minus 4ac, all of which is over 2a. So -b is +4 square root of, and b squared -4 squared is 16 minus 4ac. So that would be 4 times 1 times -3 is a total of +12, all of which is over 2, because a is equal to 1. So I have 4 plus or minus the square root of 28 over 2. And I'm going to simplify this radical down. 28 I can write as 4 times 7, so this would be 2 root 7, all of which is over to 2. Now divide everything by 2. And so I have x equals 2 plus or minus the square root of 7. So there's my two x-intercepts. I had to use the quadratic formula, and I will write them as points, since it's always a good idea when you're looking for points on a graph like intercepts to write them as coordinates. So that would be either 2 minus root 7 and the y value is 0, or 2 plus root 7 and the y value is 0. So there is my y-intercept. You see that one was pretty easy because I just had to stick in the x value. And my x-intercepts, which can get tricky if you have to use the quadratic formula. Hopefully it's something factorable and nice to solve, but it's not going to be in every case. One more example here. Again, I always like to start with the y-intercepts. So we're going to go y-intercept and x equals 0. So that would be 5 times 0 squared plus 0 plus 4. So y is equal to 4. So x equals 0, y equals 4. There's my coordinates for the y-intercept. Those ones should be usually pretty quick to run through. Now I'll start with the x-intercept, and we know y is equal to 0. So that's 5x squared plus x plus 4. I'm not going to spend time trying to factor this. You can try it if you'd like, but I'll tell you right now that it is not factorable. And so I'm going to now resort to the to the quadratic equation. And so the quadratic equation, that would be -b plus or minus the square root of, well, b squared is still just 1 minus 4ac. So 4 times a times c is 80. So I have 1 minus 80 under the square root. And you can see that there's going to be a problem already, all of which is over 2a. And 2 times 5 is 10. So you can see right away that there's a problem, because 1 minus 80 is -79. If you get to a point like this, where you have no real solutions to this quadratic equation, what that means is that there's no x-intercepts. We can tell that this is an upwards opening parabola. I don't know where the parabola is, but I do know it's somewhere above the vertex is somewhere above the x-axis, because there's no solution to where the parabola is equal to y equals 0. So this had no x-intercepts, and I could tell that because my quadratic formula was unsolvable.